Dear students, now we are going to discuss various DSP functionalities in detail. The major DSP functionalities are multiply accumulate function, simply MAC unit, circular buffering, pipelining, single instruction multiple data function SIMD, FIR filter design, fast Fourier transform, etc. In this lecture video, we are going to discuss multiply accumulate unit, circular buffering and pipelining in detail. Multiply accumulate unit is a fundamental block of digital signal processor. It performs multiplication, addition and accumulation operations. This is the block diagram of MAC unit. In processor, first we have to store the input data in the registers, then it is processed. Finally, the output is stored in that register itself. So here we have to store that input data's multiplier and multiplicand into the registers X and Y, then given as input to this multiplier. The output of this multiplier is given as input to this adder. The another input to this adder is taken from the output of accumulator. Okay, so it represents the repetitive MAC operation. So this is the block diagram of MAC unit. DSP processors are designed to perform repetitive MAC operations. Example, FIR filter response. It can be obtained by using the formula y of n is equal to summation I is equal to 0 to n minus 1 bi x of n minus I. Here this capital N represents the length of the FIR filter, bi represents the filter coefficients and x of n minus I represents the sampled input data. Okay, so the FIR filter response can be obtained by using the repetitive MAC operations. For that we can use multiply accumulate unit. It can be done in two stages. One is to multiply the given numbers. The second stage is to add the results and then accumulate the output to the previous outputs. Okay. The major advantages of this MAC unit is to determine the power consumption and the speed of the overall system. So here it provides high speed and low power MAC operations. So next we are going to discuss circular buffering functionality. It is an efficient method of storing the input data in a real-time digital systems. Here the DSP processor uses a dedicated hardware to provide the fast circular buffering. So in real-time applications we need to store the data in an efficient manner. For that we are using that methodology, circular buffering. So this method checks the status of the data and updates it continuously. In this circular buffering method we are going to use data pointer which will interpret the content of the circular buffer. So the data pointer always points to the newest data inserted to the storage location. The circular buffer acts like a first in first out buffer. So here we can consider 8 storage area. Okay, this value is x of n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 7. The newest data here it is x of n. This all are the previous data. Correct? X of n minus 7 is the oldest one. Okay. So this can be represented as Fifo buffer like this. Okay. So data pointer always points to the newest data inserted to the storage area. For each new value it performs only a single memory write operation. No need to change the other data locations. So for that we can consider this 4 storage area. Here 4 values are stored. X of 0, x of 1, x of 2, x of 3. Pointer always points to the newest data. So here the newest data is x of 3. Okay, this is the first in value. Okay, so this can be represented as first in first out term. So here x of 0, x of 1, x of 2, x of 3. This is the newest data to this buffer. Okay. So if we want to add one more data, that is x of 4 to this storage area. So what we are going to do means we are going to simply replace the oldest data by this newest data. Oldest data, that is first in first out. Whichever is inserted first, that has to be removed. That is first in first term. So x of 4 is stored in this x of 0 position. There is no change in this x of 1, x of 2, x of 3. That's what given here. For each new value, it performs only a single memory write operation. Do you all understand that? So the position of the newest sample moves forward by one memory location. Okay. If you want to add one more new data to that storage area, that is x of 5 means it is going to replace x of 1 value. Okay, that is the next oldest one. Okay, so next we are going to replace that x of 1 with this x of 5. So when the new sample reaches the end of the buffer, it jumps back to the beginning of that buffer. This is the concept of circular buffering. The circular buffering is an efficient method of storing the input data in a real-time applications. So let me show you the difference between linear buffering and circular buffering here. So in case of linear buffering, for example, we can take the same 4 datas here. Here we can store it like this. So x of 0, x of 1, x of 2, x of 3. If I want to insert or store a new data to the storage area, what will happen means this x of 0 is removed. This x of 1 is moving to this position and x of 2 is here, x of 3 is here, and then x of 4 is stored in this position. So there are 4 memory write operations occur. But in case of circular, what will happen means for the same 4 storage area, okay, so we can take the value like this x of 0, x of 1, x of 2, x of 3. Okay, so if I want to insert x of 4 to the storage area, what will happen means instead of moving all this data to next memory location, it is going to replace this x of 0 directly. So there is only one memory write operation is required to store this newest data. Correct? Here 4 memory write operations are required. Here only one memory operation is required. So this one is an efficient method. That's why we prefer circular buffering in digital signal processor. Do you all understand this? Next functionality is pipelining. It is mainly used to improve the efficiency of the digital signal processor and its performance. The different phases of execution of instruction can be carried out in parallel. So here there are 4 basic phases available. One is fetch, decode, memory read and execute. Fetch means it is going to fetch the next instruction to be executed from the program counter. Okay. So at the same time, the instruction in the instruction register is decoded and the program counter is incremented. Then the memory read is going to read the data from the data bus or write the data into the data bus. Finally, execution. It executes the instruction in the instruction register. So that's what given here. Okay, 4 stages of TMS320C54X. Okay, at a single clock cycle, we can do process on 4 instructions. Okay, so each one is doing with fetching, decoding, reading or writing and finally executing. So this will increase the efficiency of the signal processor and speed up the processor. Okay. In recent digital signal processors, 6 stages are also available. So that is prefetch, fetch, decode, access, read, write and then execute. Okay. So it will increase the speed of that operations.